Okay, so this is the next video. We're going to talk about the derivation of the law of cosines. So in other words, we're going to do the proof. So this is PC.G.4. You have to know this for the test. Okay. So we're going to prove it from two different situations. The first one's going to be the acute triangle, and the other one's going to be the obtuse triangle. So what we need to do here is, we've got these two triangles. Again, they are the same exact triangles, but it's the way that you draw lines through it that makes it different. We're going to use these two triangles to solve this question. Okay, so over here we end up with, we have again A right across B, C is right across C, and then B is right across B. Okay, so in that case, the first situation, we're going to have a line down the middle. So in that case, if it's a 90-degree angle, we have the altitude. In other words, my H. Okay, the other one here is again like this, 90-degree angle. Again, it's the altitude. That's going to be my H. Okay, so in these two triangles, in this triangle in particular, okay, sine of A is equal to, sine is opposite on hypotenuse. So sine of A is equal to opposite, which is my H, divided by my hypotenuse, which is my C. Okay, so sine of C here, again, C is equal to hypotenuse over A. Okay, and then for this situation, we combine these together. H in this case is equal to C times sine A. And then this one here is equal to A sine dot sine of C. Okay, if you combine these together, H is equal to H, we end up with C times sine of A is equal to A times sine of C. So if you're move everything over, you end up with sine of A over A is equal to sine of C over C. So this is part one of the proof. Now, the next part here we're going to talk about is, again, the same triangle, but use another ratio. Okay, so if we draw another line over here, and again, this is an altitude. So sine of angle B here, sine of this one is going to be opposite on hypotenuse. My hypotenuse is 6 in that case, opposite on hypotenuse C. And an angle C in this situation is going to be opposite H over hypotenuse B. Okay, so again, same thing we want to do is H is equal to C times sine of B, and then in this case H is equal to B times sine of C. Okay, again you equate them together, you end up with C dot sine of B is equal to B dot sine of C. So writing end up with sine of B over B, move this down, is equal to sine of C over C. Okay, so if you combine these two things together, you have common terms. If this is equal to this and C is equal to this, therefore we can write the conclusion that sine of A over A is equal to sine of C over C, which is equal to sine of B over B. Okay, so here we established the relationship between sine of A over A, sine of C over C, and sine of B over B. Okay, it doesn't matter, the order is just irrelevant in this situation because it's all equal to each other. Okay, if you don't know how this works, just turn your head and look at how this one works, the opposite on hypotenuse. So everything we do here, everything is using sine. Okay, so the next example over here, we're going to talk about the law of sines using the obtuse triangle. So in case obtuse means we have an angle that's greater than 180 degrees. Okay, so the first situation here, let's draw a line right across over here. Okay, again, the altitude is the angle from the base to the tip. Okay, and it forms a 90-degree angle. So sine of C, again, angle C is opposite on hypotenuse. Okay, so that's H over B. And sine of B, again, we have B, angle B, sine of B is opposite on hypotenuse, so it's H over C. Okay. So in this case, this one becomes H is equal to B times sine of C, and this one H is equal to C times sine of B. Okay, so combining these together, you end up with B times sine of C is equal to C times sine of B. So you're rewriting this, ends up giving you sine of C over C is equal to sine of B over B. Okay. So we established the first relationship. Okay. So the next one here, sine of A. Okay, for this situation, we have to use another altitude. In case we have to find a way to express b. In that case, my altitude here is going to be a line over here. Again, 90 degrees from the base to the tip. In that case, this is my height. Okay, so in this case, you can also rewrite this part here as angle A. Another reference angle for angle A. Okay, in that case, this should be capital letter A. Okay, so let me rewrite that. Capital letter A, and you can use this as A prime. Okay, so sine of A in this case is going to be opposite, which is h, over hypotenuse b. Okay, and angle B, again, angle B is going to be opposite over hypotenuse A. Okay, so this one we're writing gives us h is equal to b times sine of A, and this one gives us h is equal to a times sine of b. So rewriting this gives us, equate these together, you end up with b times sine of A is equal to a times sine of b. So rewriting us gives us sine of A over A is equal to sine of B over B. So over here, let me just rewrite this so it's clear. This is this relationship we established, and this is just equating to get that. Okay, so if angle C over C is equal to angle B, that means if angle B, sine of angle B over B is equal to sine of A, they can say sine of C over C is equal to this, which is equal to this. So we establish a relationship that sine of C over C is equal to sine of B over B, which is equal to, so this reading, you get sine of A over A. Okay, again, we establish a relationship of the sines. So again, the law of sines is using sine to find all the information. Okay, so if you get stuck on how you do this, just make sure the way you draw your line, it's right across. Okay, the height will always be on the numerator, and my side will always be the denominator. So in that case, opposite over hypotenuse. In that case, my b is equal to sine of b is equal to h over a, and then you have a. So sine of a is equal to, in this case, h over a. Okay, okay, so we have this. So putting everything together, we end up with this. So in that case, let me just finish this up. We have this relationship, and we have this relationship. So combining these two gives us this one. So again, this one combining with this gives us this one. Okay, so it should be pretty intuitive of how we find this. Okay, so after this, we're going to do, on Tuesday, we're going to talk about the side-side angle. This one's going to be the one that's called the, what do you call it? Ambiguous case, because you might end up with one triangle, two triangle, or no triangle whatsoever. Okay, so that's all for today. Okay, so this is again PC.G.4. So just to keep your minds, keep you informed what we're going to do. Okay, so again, you got to know these two for the test that's coming up whenever. Okay, so that's it. Okay, I will post the homework in a little bit. So once you finish watching this, you should be good to go. Okay, so if you think I'm speaking too fast, then you can slow down the video. It's up to you. Okay, see you guys.